Good morning, 8th grade. Welcome to day 2 of week 8. Today is May 12th. I just want to take you through what you are going to be doing for today. I just want to mention a couple of things. I feel like some of you were struggling at first with yesterday's lesson, and I want to just remind you because some of you I was like telling or asking, did you look at my video today? Before answering your questions, and every morning I post the link here. It takes you through the entire lesson. I guide you through a few of the problems, so I would use this as a resource first. See if that helps, because I'm finding that I'm copying and pasting those links to not just one person, a few people. I'm finding aren't using my videos. So I just feel like they're useful. I'm not, I hope I'm not wasting my time, but hopefully they're useful for some people. And then there's also the takeaways. I post every morning at 8:05, and they just take you through the steps that were reviewed in the lesson, and sometimes there'll be like a additional picture or another link for you to use. So just keep in mind to check those out on the stream daily. Okay, so I'm going to click on the classwork, go to day 2, I'm going to click on the lesson, and then here's the lesson. Today we're doing elimination word problems. So I'm going to use the larger version. You have your warm-up. We noticed that we can we can actually multiply only the top equation. I'm not sure which one I did for this. Let's see. Oh, okay. I multiplied both of them. So I tried to eliminate, it looks like, the x. So I multiplied the 6 up top for the x, and then I changed the 3 on the top to the bottom to negative so that I got opposite coefficients. When I add, my x's would eliminate. I would be left with the y variable to then get y equals 15, and then I plug it in and I'm able to solve for x to get my final solution of negative 8, 15. Okay, moving on, this is the same chart from when we did the word problems before. I feel like it offers a lot of keywords that we see come up, so just as a reminder of some words and what they indicate, the operation indicators. We'll start with our first one. So we have Nathan sells 5 cupcakes and 6 lollipops for $10.75, and Olivia sells 3 cupcakes for and 4 lollipops for $6.75. How much do they cost? So step 1 would be to identify our variables, and our variables in this problem would be x for cupcakes and y for lollipops. We then would want to write our system of equations. So one equation will be about Nathan and one equation will be about Olivia. So if we look back at the problem, Nathan sells 5 cupcakes, so that would be 5x, and plus 6 lollipops, so 6y equals 10.75. And then we have Olivia, she's selling 3 cupcakes, so 3x, and so plus 4 lollipops, 4y, equal to 6.75. All right, so second step would be to write your system. That's what I did here as I was saying it to you. And then we're back to what we worked on yesterday. So we noticed that our x and y variables need to be multiplied, both equations, by some constant. So I'm going to decide to eliminate my x's. So I'm going to put my parentheses. I like to add, so I normally make sure that they come out to opposite products. So I'm going to bring my 3 up here and multiply the top by 3. And I'm going to bring my 5 down here, make it negative so that they're opposites, and bring it down. And now we distribute. So I'm going to distribute my 3 to everything on the top. So we'll get 3 times 5x will give me 15x. 3 times 6y will give me 18y. And 3 times 10.75 gives me 32.25. Okay, so that's my top equation. Now I'm going to distribute the negative 5 to everything in my second equation. So I'll draw my arrows. Okay, So we have negative 5 times 3x will give me my negative 15x, which was why I did this, right? My 15s will eliminate because they're opposites. Negative 5 times 4y gives us the negative 20y. And then negative 5 times 675 gives us negative 33.75. Okay, so since these two are opposites, we're going to add. I'll make my lines down. Okay, and let's add them up. So 15x plus negative 15x cancels. We're left with 0 here. Okay, 18y plus negative 20y. That's going to give me a negative 2y. Okay, and then finally 3225 plus negative 3375 gives us negative 1.5. And then the last thing we do, we'll divide to get our y by itself. And y would equal the quotient of negative 1.5 and negative 2. So y equals 0.75. And remember that y was representing the cost of the lollipops. So it's okay that we're getting a rational number. It means that our lollipops are 75 cents each. Okay? Then we have to figure out the cost of a cupcake. So we use one of our equations. I'm going to use the original first equation about Nathan. So I'm going to rewrite it. It would be 5x plus 6y equals 10.75. I then take my value of y, which is 0.75. I'm going to plug it in. So it would be 5x plus 6 times 0.75 equals 1075. Okay, and then we would keep solving. So 5x plus 6 times 75 cents is going to give us 4.5 equals 10.75. And then I would subtract the 4.5. Okay, so I'm left with 5x equals 6.25. Divide by 5. And we'll get x equals 1.25. So again, our x was representing the cost of cupcakes, so it's okay that we're getting this rational number. So my solution will be x comma y, so 1.25 comma 0.75. So 1.25 comma 0.75. So that's my solution. And then the last thing you want to do, all your work is in the lesson as well, is relate it back to the problem. So you want to make sure that you say, okay, cupcakes are $1.25, lollipops are 75 cents. All right? So pretty much the same thing we did yesterday, just now you have to come up with that system by yourself given the word problem. Okay? Similar to the word problems we've already done. I feel like they should be getting more comfortable with you. So the steps are there. Step 1, you identify your variables. Step 2, you write your system of equation. Step 3, you're going to solve using elimination with multiplication. And then step 4, write your solution. Step 5, relate it back to the problem in a sentence. Okay, I'm just erasing my board. I'm sorry if that was a little bumpy. Okay, so now there's another word problem. The difference of 3 times the number x and y is equal to negative 4. 2 times the number x plus 2 times the number y is equal to 72. Find the numbers. So in this one, they actually tell you the variables. X is going to be the number x and y will be the number y. Then we have to write our system. So we would use those operation indicators to figure that out. So the first one would be the difference of 3 times the number x, so 3x, and y minus y is equal to negative 4. And then the second one said 2 times the number x, 2x, plus 2 times the number y, 2y, is equal to 72. So we got our system. Then what we do with this system is we have to figure out, okay, what can we multiply by so that one of our variables can be eliminated? And I'm noticing that if I multiply the top equation by 2, then I'll be able to eliminate my y's. So I only have to do one multiplication this time, which is kind of nice, right? Less work. After distribution, you'll see we'll get 6x minus 2y equals negative 8. If we add, our y's will eliminate. We would get 8x equals 64, and then x would equal 8. Once we have what x equals, we can use any of the 4 equations we have to figure out y. I use the bottom one. So I get 2x plus 2y equals 72. I plug it in for x. I get 16 equals 2y equals 72. I'm sorry, 16 plus 2y equals 72. Subtract the constant 16 from both sides. Divide by 2. We get y equals 28. So then you write it as a solution, 8, 28. Relate it back to the problem. The number x is equal to 8 and the number y is equal to 28. Okay, I think there's one more for you guys to try on your own. Talking about tickets to a movie theater, you got the cost for adults, the cost for students. You have that this group was 8 tickets and it cost $52.75. So this system, one equation will be about the amount of tickets and one will be about the cost. We've seen problems like this, so I hope that we're comfortable with it, right? We know that x are the adults, y are the students. One equation would be x plus y equals 8 because that's just the amount of tickets sold. And then the other equation would be with the cost. So it could be 7.25x plus 5.50y equals 52.75. Be mindful which variable you use for x because I know before some of you started swapping these numbers. If you make x the adult tickets, then the cost for the adults needs to be with the x, so be mindful of that. With this system, to eliminate a variable, we can either multiply by the opposite of 725 or the opposite of 550. I think I multiplied by the opposite of 550, yeah, negative 550, and then I take you through all of that here, okay? Make sure you relate it back to the problem at the end. For your exit ticket today, you have 2 problems to complete. They are given in a Google Doc, so you are responsible to show the work on that Google Doc. Some of you have been comfortable submitting that digitally, which is fine. Others of you are sending it to me using any of the other options provided. So I'll just show you what that looks like real quick. There are your options. You'll have your Google Doc provided here. The word problem is at the top. And then we gave you this graphic organizer to remember everything that you need to do to show the work necessary for the problem. So you have this problem about the bookstore, and then you have the second problem about the ferns and the lilies. Okay, make sure you do both. Great job today, and I hope you guys are staying safe. Take care.